Hello, we're outside again. Okay, so today we get into actual algebra, and we basically start with the simplest type of equation and then move out. So here's the simplest type, and they're technically called a linear equation. So it's got one variable, x, a and b are constants, and it can be written in that form, ax plus b equals 0. So it might take all kinds of different forms, but it can be reduced to that form at its simplest. And here's some examples. So like when you look at something like this, even if you've never done an algebra equation before, you can probably just say x is 15. And then it's one of those things where you kind of have to think about, how did I do that? Like, you kind of just said, okay, 15 minus 3 is 12, right? Obviously. But what you really did in your head, even if you didn't think about it, is you started at 12 and then you went 3 more. You did 12 plus 3 is 15. So really, it's that simple. That's the process. We're just going to learn how to do that with anything. There's another example. You probably couldn't jump right in your head to what x was in that case, because there's a couple of different x's and there's some fractions and whatnot. But with the same exact process, we will solve these soon. Okay, so just some terminology. Like I already said, the solution of the first equation is x equals 15. So we say that the equation is true in that case. And then we say 15 is the solution of the equation. Now, in this case, there's only one. We're going to see stuff in the future where there's more than one, so we say a solution, but that doesn't matter for now. So you could also say that if x is 15, that satisfies the equation. Those two things basically mean the same thing. Okay, so when I say solve an equation, I mean you tell me everything that x could possibly be to make that equation true. Here's your most basic property of algebra. That it's one of those things, it's like an axiom. It's true just because it is. If a equals b, then a plus c equals b plus c. Okay, so for our purposes, that means if I have an equation that's true, a equals b, something equals something, I can go ahead and add or subtract any number I want as long as I do it to both sides of the equation. That's technically called the addition property of equality. I don't care if you remember what it's called. Okay, so now that's just a move that you're allowed to do. So solve this one. X minus 5 equals 12. Again, you already know that the solution is 17, but here's how to really do it, is you just add 5 to both sides of the equation. And the point of that is to get rid of this. So you want to get x by itself, or isolate x. We'll talk more about that in a second when it's harder. Okay, so add 5 to both sides with the goal of getting rid of this 5. X minus 5 plus 5 equals 12 plus 5. Obviously, x minus 5 plus 5 is just x. And 12 plus 5 is 17. So I kind of did two things at once with that one move, but y'all see what I did. And you don't even need to write it down. It's super easy just to mentally check. Does 17 minus 5 equals 12? Yeah. Okay, here's the comparable multiplication property of equality. If a equals b, if we have an equation that's true, I can go ahead and multiply any number I want by multiply both sides by any number I want. Now with the caveat that if c equals 0, this kind of doesn't hold, because you can take something that's not true and multiply both sides by 0 and make it 0 equals 0, but don't worry about it, because why would c ever be 0? Okay, so now we have this move in our toolkit. So this is a linear equation. It just doesn't have a little plus b in it. But to solve 4x equals 28, again, you probably already know 4 times what is 28? 4 times 7 is 28. So the answer is 7. But really, how did you do that? You did 28 divided by 4. Even if you don't know, that's what you did. So that's what you do here. But instead of dividing, we're going to multiply both sides by 1/4. You know that that's the same thing as dividing by 4. So if you think about it as dividing both sides by 4, I can't really fault you. This is just the way we're going to do it in this class, just so we can use the same technique on basically everything. Okay, so the 4 and the 1/4 are reciprocals. That's where I got it. So those cancel each other out and just become 1, and then 28 times 1/4 is 7. 1 times x is kind of redundant. I just wanted to show you that step this first time, because it doesn't do anything. So x is 7. Very easy to check. You don't even have to write it down. Later we'll do harder equations that we will actually manually check. 4 times 7 is obviously 28, and 4 times nothing else is 28. Okay, maybe you can't do this one in your head. and that's good. But same exact principle. The reciprocal of negative 3/5 is negative 5/3. And you know that if you multiply that side of the equation, the left side, by negative 5/3, the negatives will cancel each other out, and the 3/5 and the 5/3 will cancel each other out. Reciprocal means the same thing as multiplicative inverse. We just normally say reciprocal. So there you go. On the left side, we just have 1. And then on the right side, we have whatever we have. 12 times negative 5/3 is negative. It's going to be negative 60/3, or you could just simplify it and do 4 times 5. Either way is negative 20. And then, yeah, let's actually check this one. So let's check that negative 3/5 times negative 20, in fact, equals 12. So again, simplify however you want. The negatives cancel out. It's basically just 3 times 4, or 12. Okay, so you don't have to do that, but boy, it sure helps, and especially on an exam or something, if you do that, you just know that it's right, and you can move on, with a peace of mind. Story problem. The total cost on a new kayak is $862.92, $63.92 of which is sales tax. Find the cost of the kayak before tax. I don't know why I'm capitalizing kayak. Okay, so that's the total price. We want to know the price before sales tax. So all you really have to figure out here is that we're subtracting. We're subtracting $63.92 from the total. Right, and so I'm jumping a little bit ahead of the book here, and I'm having you actually create equations. So when you make up a variable, that's called declaring a variable. You're just making something up. In math, we can do that. So that's what x is. You can call it x. I'm going to call it k. And generally, we want the variable to be the thing we're trying to find, because then once we find it, we're done, right? So you could call it x. I like to call it like the first letter of whatever we're doing. I don't know why. It doesn't matter. I'm not going to punish you for using some other random letter of your choosing. Okay, so we know whatever the price of the kayak was, we added $63.92 to it, and we got $862.92. So now we know this is a linear equation, and to solve it, you just subtract $63.92 from both sides. Right, you can ditch the units. The dollar signs are units. There's no reason to put them in the equation. It wouldn't be wrong, but I like to just put it back in at the very end, because remember, I am kind of a sticklery about including units. Okay, subtract that from the left-hand side. All we're left with is k, right? It's isolated. And then we just have to do $862.92 minus $63.92. So however you do that, for right now, you can use a calculator. I have faith in you. And there you go. K is $7.99. And then you could write $7.99, or you can just put a dollar sign. There you go. Or you can write a nice complete sentence for me and make me really happy. The original price of the kayak was $799.